to my last Advent of Code video. It's on day 7. This is directed at my students who have attempted this problem but haven't succeeded. So I just want to go through how I did it. It could be a bit of a long one because there's a bit of complexity, but I'll see what I can do to avoid that. Okay, so this is what the data looks like, right? So there's a lot of CDs and LSs. Okay, these DIRs, they're completely, I don't need to know about them at all. Right, and there are files and their sizes. So we need to know what directory we're in. So we've just changed into this directory, but of course there were other directories before that. So we need to know what directory we're in and what files are in that directory. So here's a sample data that we'll be looking at more specifically. Okay, and I'm going to discuss the design here. So maybe as a first point, I'd just like to point out that there are chunks of this input that are important. And so basically I don't want to just read it line by line. I want to read it chunk by chunk, and every chunk begins with a $sign. So I want to process the command and its output, one command at a time. Right, that's a more logical thing. But you know, beyond that, we've right, these are the only lines that we care about. So we need to know what directory we're in, and now we know that there are 2 files in the root directory. And then we CD to A, and we see those, and so on. Then we CD to E, right, and see those, and then we go back one level and go back another level, and then into D. And I've just realised what we get from that is now I've missed. Excuse me a sec. What we get is basically a table. What's that? 1 4 8 4 8 5 1 4, and okay. So when we read this sample input, then what I want first of all is a list of files where each file has a directory, a name, and a size. So these are like rows of a database, and these the directory name and size are the columns. I'm abbreviating directory to DIRE just so everything's 4 letters, just, you know, whatever. Okay, and this is not solving the actual problem, but it's processing the data into a shape that will allow me to solve the problem. Okay, we'll then calculate the directory sizes. What we'll do is create an initial dictionary that has its keys are each directory, and the values start at 0, and then each time we will then read through each of these, each of our files, and when we read a line like this, we know that the directory A/E needs to increase by 584, and the directory A needs to increase by 584, and also the root directory. So I'll just correct my comment here. There we go. All right, so this will impact the size of 3 directories. Okay, and then this gives us a nice predictable amount of work to do. All right, so for our sample input, we're going to process that into this many files, and the real input has about 250 odd files, so not a huge amount of data. And then for each one, we're going to go through, and however many levels the directory is deep, that's how many steps we're going to take, because we'll have to add 584 to 3 directories here. This one will be adding 62,000 596 bytes to the A directory, and also that same amount to the root directory. So if we have here, we have, how many lines do we have? The damn thing's not telling me. So about 10 lines there. And if the average affects 2 directories, and that means we're doing 20 steps. So for our real data, if we have 250 files and the average directory depth was 400, it was 4 levels, then we'd be doing about 1,000 pieces of work. So right off the bat, I know that this is very achievable. Note that I'm not putting anything in a tree structure. I'm flattening it out to a list. I'm repeating information. So I'm repeating that this is /A, this is /A, this is /A, whereas a tree would have one entry for the /A and then one for the entry underneath that for the E. A tree structure is computationally much more complex, so I'm flattening it out to a list. All right, let's have a look. So in my code, now I'm presenting some code here to start with, but then I'm going to develop code in the video, more educational that way. These are just some imports that I have, not necessarily using them all. This one's very important, data class. This just does pretty printing. We're not going to need any math. This is regular expression, not going to need that. This is iteration tools, probably not going to need that. Input lines I've had in previous videos, so now my comments out of date. That's a problem with comments, they do get out of date. So anyway, I can input the lines. This prints a list from a given sequence. Paragraphs was used in an earlier problem. Extract integers from line. I could have got rid of these, but I just thought I'll show you some code that I've got lying around, and you can take a look and experiment with it if you like. So in an earlier problem, I needed to extract each integer from a line, so I did that. This uses a regular expression, so it just picks out the integers and ignores the rest of the text. That's the nice thing about it. Okay, chunks. Now this is important for this problem. All right, so I'm going to pause here because I said that we are going to read the input one chunk at a time. So if I'm going to run this, it does nothing, but I just want to demonstrate the use of chunks. So I've got a couple of sample arrays here, and what I can do is I can call chunks on numbers, and I would say I want to put it into odd, like I want each chunk to start with an odd number. Okay, now odd's not defined, so I'll define it. Odd x, return x mod 2 is 1. So that's done. And now I can call this, and it gives me back a generator. Well, I want to see what's in the generator. So I can go list chunks numbers odd, and there we see we see them, right? Now I can get the generator, and I can go PL and then get the previous result, and here I can see the chunks better. So PL is just to print in a list form or something, just good for debugging. So you can see here that it's broken the numbers into several lists, broken one list into several lists. Each one begins with an odd number. Now it's possible for the first one not to begin with an odd number. So if I said even return x mod 2 is equal to 0. Now the first number in our list is odd, but if I right, now the first one has to go somewhere, right? So it's not the case that every single chunk starts with an even number. The first one has to go somewhere. All right, so this chunks is pretty useful. I'll be able to separate it into into the chunks that I need. Now, I passed a function in here, even. If you don't want to write a function, you can give an anonymous function like this. Okay, and I'm going to just wrap this in a print list as well. Okay, so that has the same effect as before. So I passed the function in without defining the function. And so like I could say, let's do chunks based on, has to start with a multiple of 3, or a multiple of 5, right? Or a multiple of 999. Now there's only one chunk, right? Because nothing can start a new list. Okay, and I've got some names here as well. So I want to say I'm going to split this into chunks by saying the length of the name is 3. So anything that's a 3, there we go. Right, so Susan has to go somewhere, but then every other chunk has a 3-letter name to begin with. All right, so chunks is obviously useful, and because it's so important, I wrote this function called test chunks, right? So I can call that here. Okay, and nothing happened, which means there were no problems, right? Because these assertions all passed. So, I've tested on a variety, well, just 4 things, but just with different behavior at the end, like a different number of relevant things at the end. Okay, digits and matrix size, just, useful things for earlier problems. Okay, so problem 7. All right, I'm not presenting much code to begin with. Now, in this problem, a directory is a tuple of strings, and the path string function creates a conventional looking path for the directory. So what I have here is a data class, right? I told you that I'm going to store things with a directory, a name, and a size. Well, this is a nice, easy way in Python of achieving that. If there was no such thing as a data class, I could achieve exactly the same thing, but I'd have to write more code. So I'm just going to clear the screen here. So with this code, I've got a class file. I've described what the properties of the file are, and I've got 2 methods on the class. I'm just going to demonstrate what all this means. So I can go f equals file. Oops. Now, a directory is not like a string separated by slashes. It's a tuple, right? So say, right, so I've got a directory there, and the name of my file can be doom.exe, a classic first-person shooter game, and the size, well, okay, that big. All right, so I just created a file object, and if I ask it to be printed, then I get that, right? It shows what the properties are. The directory is that, the name is that, and the size is that, okay? Now, I've defined a string method here with the double underscores. That's a special one. So if I now ask it to actually print it as opposed to just show it on the screen, then I get a nicer way of looking at it. And you can see here, so when you call printf, or even just string f, right? So the conversion to a string, it goes looking for this. Now, if I hadn't defined this, then it would have just fallen back to default implementation, and I can get the more detailed one like that, and that's what we saw up here. So REPR is short for representation, and I could actually define my own representation in here if I wanted to. I'm not going to, because then it'll throw away my data. So I could define double underscore REPR in here and make it give a different return value than that. Okay, the point really of a representation is I can copy that and paste it, and it's valid code, right? That's the point of a representation. Okay, and I can go f.path and get that, right? That's calling this method. Now, it looks like a function, but it's called a method. A function that's defined inside a class is called a method because it takes the object as its implicit argument. So I went f.path bracket bracket. I didn't provide any arguments, right? But there is an argument here. That s is short for self, as in the object itself. All right, so a bit complicated. You know, I could make a whole video about this, but I just want to give you a taste, right? The important thing is I need a way of representing. I need a way of turning my data into like this database style thing. You know, rows of a database, and this a data class is a nice good way of doing that. An alternative would be to use just a tuple, right? So if I were to say file is, you know, and I just put the, you know, let's say I was representing as a string, because the representation doesn't really matter. That's the directory. That's the thingo, and there's the size, right? So that could be my representation of a file. Okay, but now there's nothing file-ish about it. It's just literally a tuple of 3 objects. It's a triple. I can't then see what I can do. Here's my f object. I can now go f.size, for instance. Oops. I can go f.size and get that. I can go f.name. I should have pointed these out right at the beginning. Right. So I can actually get access to the actual data in there. Whereas if with my f2, it's an anonymous triple, so I can't do that, right? It has no object name. All I can do is things like that, you know, and that's a bit that code's a bit uglier and more fragile. Okay, moving right along. So what we really need, I'm going to take a bit of a top-down approach here. So problem 07 with an optional subfile. I'm going to get the lines, so input lines from day 7 and pass that on, and I'm going to just sort of, I guess, pause and run a lot of things as we go. So if I say that's subfile 1, right? So I run that, and there's all my lines, right? One line at a time. If I pretty print it, then we'll see it more as a Python structure rather than right? So we can see that it's a list of strings, okay? All right, now we don't need to see that. So what we really want is chunks. I want to call my chunks function to give the lines, and what defines the beginning of a new chunk. So oops, it's pretty simple that the first character is a $sign. Right, the first character of the line is a $sign. That's what defines a new chunk. So let's just see what happens when I run that. Okay, I get a bit of a problem. Oh, right, okay. So that needs to be a double equals. Okay, so chunks returns a generator, right? As in it's a promise to give you one at a time. It doesn't give you the whole lot back at once. So if I print the list, that will print every item in there. Oh, okay. Can you see what the problem is here? Chunks, what I've got here is the name of a function, and it's saying function object is not iterable because it's trying to call for x in chunks, right? I named it the variable underscore chunks, okay? You might think of a better name, but I couldn't. Okay, so there are all of my chunks. Each chunk is a list, and each chunk begins with a command. And so now I'm going to be able to process these. Okay, I can process them into file objects. Now, obviously, that is not going to produce a file object, and that is going to produce 2 file objects. That is not going to produce a file object. That's going to produce 3 file objects, right? This will be ignored. Okay, this is just telling me that I'm going to produce some file objects here. Okay, what does this do? This changes the directory. So I need to know what the current directory is. And when we change the directory, I need to update the current directory. And that includes going up a level or going back to the root directory. So that's fairly complicated. I'm not going to do it in this. I'm going to defer this to a function. So process chunks into files. And I pass in the chunks, right? Not the lines, the chunks. And I'll print the list of files when I get that. Okay, so we've got some work to do here. Now I've done this work already, and I must say my first attempt, it took me a lot of trial and error, design, thinking, and all that before I got code that worked. I'm just presenting finished result here with a bit of narrative and iteration as we go. Okay, so I need to define this function, right? And I'm going to, I won't call it chunks, I'll just call it x's. Okay, and I'm going to make because this is complicated, I'm going to make a bit of a comment. X's is a chunk, like one of the following. Right, so I could literally copy right, so it's like, and we return now. We return sorry, I've made a little mistake here. Here's my mistake. I'm going to have a function that just does one chunk, right? And I'm going to have a thing that does multiple chunks, right? Now, the chunks into files is a reasonably simple function because it hands over most of the work to a single chunk, right? So in the spirit of working top down, all right, remember we're in plural here, okay? So we've got some chunks, and what I need to do, I want to turn it into files. So I'm going to start with an empty list of files, and I'm going to keep adding to it. I'm going to have the present working directory is an empty tuple, and then I'm going to say for x in x's. So x is a simple chunk now. I'm going to process the chunk, right? And in order to process a chunk into files, then that needs to know what the current working directory is, and it needs to be given a single chunk, right? Okay. And so what's this going to return, right? What is this function going to return? Well, the working directory could change as a result of a CD, and we need to know what it is. So it's going to return the present working directory. It may change, it may not, but like what goes in may not be what comes out. And also it needs to return some files that I'm going to add to it. So I'm going to call that X files for not the show, but extra files, right? So I have a single chunk, and I ask this function to process it into some files, and it's going to give back to me the new working directory, which may or may not be the same as the old one, and it's going to give me the extra files that it found. And so what I do now is put them in the list. So I go files. Now you know about append. I'm going to use files.extend, and I'm just going to return all the extra files. Okay. All right, and then at the end of this, I'm going to return files. Right, phew. Okay, so now I need to create this, but the next level logic is done. Right, so it's now clear what has to happen here. Right, so I have a chunk, and look, it's bad design that I've called process chunks into files, and I've called that X's. So I'm actually going to call that chunks now. Okay, now each, no, I'll call it for chunk. Okay, all right, so this takes in a list of chunks, and then each chunk I'm just going to call X's, because you can see each chunk is a list, right? So X's is a chunk like one of the following. Okay, and what do we return? Well, we return the present working directory, and we return a list of file objects produced by this chunk, right? And that could be empty, because if we encounter a cd command, we're not going to produce any files from that, right? Okay, so we've established that. All right, let's see what this is going to look like. So each chunk begins with a command. So I'm going to say the command is the first of our X's, and I'm going to split it, right? So we get the dollar and the CD and the A, or the dollar and the LS, or whatever, right? So if command 1, we're not interested in the dollar, is equal to CD, then we need to do something. Otherwise, if the command is equal to ls, then we need to do something else, and there shouldn't be anything else, and so I'm going to all right, so we should never reach this line of code, and if we do, I want to know about it early and not be wondering why my program's not working. Okay, so what do we do if it's a CD? Well, what we do is we change directory, and so we need to know the current working directory and the second thing in the command, or the third one, and what happens there, right? So change directory, I need to write this function. That's going to return a new directory, right? And then I also want to return that, but I also want to return the empty list of files. Okay, so remember, we're returning two things from here. So I'm going to return the result. You know what? I'm going to make this more clear. So the new present working directory is change directory pwd and command index2, right? So, and then I'm going to return the new pwd and an empty list of files. Okay, so I need to implement change directory, but first, what do we do if we've got ls? Well, the directory doesn't change, so I'm going to return the present working directory, and I need to return a list of files, right? Well, here's my code for that. Okay, so I'm going to go make file x for x in x's starting at 1, right? So x's is our, right? So if we've got an ls, then x's 1 colon means all of that, And for each of those, I'm going to make a file. Now, dir is going to be no file at all, right? But I'm still going to make one, like it'll just be none. This is going to be a genuine file object. That'll be a genuine file object, and that'll be none, all right? So why am I doing that? I want to keep it simple. I want to do something for everything in here, all right? I don't want to be like going, oh, if this, then that, whatever. I just want to keep it simple, right? So now I've got two things I need to create, and then this is done. Now you can create functions within functions, and I'm going to do that because these functions are only useful in here. So change directory. So I need the present working directory, and I need the argument that's been given to me. Now, there are three cases. So I'm going to say if the argument is equal to the root, that's our simplest case, then I'm going to return the empty directory, right? Elif, don't know why the indentation's a bit crap. By the way, I'm doing this in Replit instead of in my terminal because it just gives me that greater opportunity to show you incremental things. Elif arg is equal to ... then we need to go up a level. Now what does that mean? Well, I can simply do this. I can go the present working directory index from 0 up to, but not including the last one. Okay, I'll demonstrate that in a moment. Otherwise, need to return the current directory with the argument appended, and here's the simplest way that I know how to do that in Python. Okay, so I'm going to spend a little bit of time demonstrating these things in the REPL over here. All right, now I don't know if I can run. I've probably got incomplete code here. I'm not going to run it. So I've got my file. Oh, I thought I had my file object. Oh, that's because I've hit run. Oh, that's a real shame. Okay, so right, I just need to actually, you know what? Directory. The only thing I care about is a directory. Just use the same thing I had before. Temp. What was it? Games. Action. All right. And for simple typing, I'm going to just do this. Okay, so there's our directory, right? So how do I get? Well, it's a tuple, right? And just like a list, a tuple is like a list that you can't change. So I can do that. Okay, I can ask for the length of it, right? And I can also do slicing. So there are three things in here. The indices are 0, 1, and 2. Like if I wanted to start at 1 and go to the end, then I get games and action, right? Well, what I want to go up a directory is to start at the beginning and just stop short of the last one. And so that gives me temp games. So that's exactly what I want. So I go from temp games action to temp games with that code. And that's what we have here. Okay, now this next one, this star is a bit of a weird thing. So I've got this directory here, and I'm going to create a list. Here's 1, 2, 3. No, I hate lists that are 1, 2, 3. 5, 3, and 9. Okay, and now I can make another list that has like 45 Sally, and then all the contents of list L, and then 3, and then none, and then all the contents of the tuple D. And there we go. So this is like an explode operator, to explode the tuple into a new one. And so I'm simply exploding the tuple in there and putting another one in and creating a new tuple. So here's my D, and if I say D2 equals, so I explode the current directory, So I've got, well, what I got, temp, games, action, and Dooms and old games. So, okay, and there we go. Right. So that gives a full explanation of this, and I hope it contains some tips that you can take away, like using tuples to represent data. They're immutable, right? So you have to create a new one. And yeah, using slices and using exploding to work with them. All right, so change directory should work. What else do I need? Make file. So make file takes one argument. Let's call it x, and I'm going to, now the x is like, so it takes something like 147, hello.txt, right? So it takes that string input and it returns a file where the directory is the present working directory, the name is hello.txt, and the size is 15467. Okay, so it's taking this text, right, like that, or that, and turning it into a file object. Now, a file needs the directory, and we know what the present working directory is because this function is inside another function. So when we say pwd, we're actually accessing, the pwd that is. Okay. Well, that's a good point. To process a chunk into files, we need to know the pwd, right? So when we so the change directory, I didn't actually need to provide that, but stylistically I felt that it was a good idea. But for make file, I mean, I could provide it. I guess you could say that if you're going to make a file, then you need to know the present working directory. Okay, I'll pass it in, but then I'll also demonstrate how it also works if you don't. Right, so an inner function can access the variables that are in the outer function, and that can be a very, very useful thing, especially when the situation's more complicated than this. Okay, by the way, a string as the first thing inside a function is literally just a comment for that function, which can be accessed over in the REPL, but I'm just not sure how. Okay, so make file. Right, so the input needs to be split into two things, right? So I'm going to say the size and the name equals x dot split, not splot, split. And if the size is equal to the word dir, then that's one of the things that we want to ignore. So I'm just going to say return none. Otherwise, I'm going to return a file object that has the present working directory, it has the name, and it has the integer version of the size. Okay, so there we go. All right, so there's a bit of logic here. There's an if and so on, like to deal with the dir, and I don't want to deal with that mess at this level. See how we're doing process chunk into files, right? And there's a fair bit of work that has to be done because you might need to change the directory, you need to create a file object, but I've kept the code here really focused on the job at hand and not focused on like the little details. It's literally, what's the command? Is it a cd? Okay, then change the directory and return that directory with an empty list of files. Is it an ls? Okay, return the current directory and then a bunch of files. How do we create the file? Well, we'll just go make file and let that work it out. All right, so all of the code here is kind of at the same level of abstraction, and that's a really important programming principle. All right, so I should be able to run something now. Let's go back to our top level. I'm going process chunks into files. Well, I think I've fully implemented that, and so I should actually be able to run this, and I'm sure there'll be an error somewhere. No. Okay, yeah, there's something we need to change, right? So I need to filter out these nones, right? That's easily done. I just didn't want to do it up front because I hadn't yet revealed that there would be some nones in there. So Anyway, this is looking good. I can see that this doesn't look so good, right? That shouldn't have a double slash there, so I'll see if I can fix that. Anyway, these files are called here, make file that for x in that, and all I need to do is say if x is not none, right? So I can just run that, and then we won't get the, well, I'll be blowed. Right, sorry. I had the thing, right, x is not none. Right, I've done this in the wrong place. I had the thing in mind, but I've done it in the wrong place. It's process chunks into files, right? So when we call process chunk into files, we always get back a list of extra files. It could be empty, and in which case extending an empty list is fine. So if I go L equals, right, and I go L dot append 4, you know about that, right? But did you know about this? If you want to extend, if you want to add several things at a time, you don't call append, you call extend. Okay, why don't you call append? Because then you've literally appended a list to the list, right? You don't want that. You want the items in the list to be put on there. So that's what extend is for. Okay, so, and if you go L dot extend, and notice, of course, I'm changing the list with everything I do here, but with tuples, you can never change it. If I go L dot extend and I give it the empty list, then that has no effect on L. So calling extend with X files, even though X files can be empty, is not a problem. Problem is X files can have nuns in it, right? And so instead of blindly extending it by X files, I'm going to go F for F in extra files if F is not none. Okay, and when I run this, I get an error because I didn't type that correctly. And when I run this, right, I get the same thing as before, but I don't have the nuns. Now, I don't need to say if F is not none. I can just say if F, right? And there we go. All right. What's next? Well, I should try to fix this. Probably. I mean, I didn't write this code today, but it's calling path string to generate that. I'm going to put some debugging in, so I'm going to go. I'm going to print D. Right, and so now every time it runs, it's printing what the directory is. So basically, it's having a problem with. So if I call path string and I give it an empty, like if I give it a tuple like that and a name, right, okay, path string is only meant to, silly me, path string is only meant to take a directory, right? Okay, I'll get rid of this. Let's just take a little bit of a look at path string. Now, if I give it the empty thing, then I get that. And when I call the path, so if I go F equals file, give it the empty thing and a name and a size. Okay, so if I go F dot path, then I've got this double slash thing. So path, it's returning the path string of the directory. So if I go path string of F dot that, then I get the slash. and then I'm doing +/+ the name. Okay, right, I think, see, it works for the other cases. I think I just need a special case in here. So if the directory is equal to that, then I'm going to return /+ the name. Otherwise, do that. Okay, I think. All right, so that's all good now. All right, now that's only cosmetic, right? These strings are not being used for anything computational, but I'd like it to be cosmetically correct. Okay, so what do we do now? Well, we need to calculate the sizes now. So I'm going to write a function called calculate directory sizes, right? And it needs to take in the list of files. Now, what's it going to give back? It's going to give back a dictionary. What should I call that? I'll call it dir sizes, okay? Now, for beginning programmers, I just did that deliberately very carefully, right? I said I'm going to create a function. So, and now say, now what does the function need to take? Oh, it needs to take that. And then what's it going to return? Well, it'd be nice if we could say return that, right? And store it in a variable. It'd be really nice if programming languages allowed us to write like that, but they don't. So you've got to do that, but still right? I'm looking at one of you in particular in my target audience of like thinking of a function but not thinking of what to do with the result, and that's a very common thing for novice programmers. Okay, so think of the function, think of what it needs to take, think of the result, and what I'm going to do, it'll return the dictionary. I'm just going to print it, and so def calculate directory sizes, and it's going to take some files, and I'm going to return just an empty directory at the moment, or an empty dictionary, and just run. Okay, there we go. So now I'm going to work on making this work. Okay, we're not far off now. So if we just return to the design document, so we need to create an initial dictionary. Yeah. So what I'm going to do, just to motivate this a bit, I'm going to say return files. Now it's going to seem a bit weird. What have I got? Oh, I haven't put a pass here to complete the function definition. Okay, so that pass is more or less equivalent to return none, so that's printing none, but I'm returning the file. So what I can do, I can say files equals the last return value. Okay, that's not defined. I'll say files equals P07 bracket 1. Okay, and there's our list of files, or better seen like that. How do I get how do I get a dictionary of directories? Well, let's start with a list of the directories. So I can say f dot the directory for f in files. So that's given me a collection of that, right? Now there are repeated things in there, so I could do this as an argument to set. Okay, and now there's nothing repeated. So I got my A/E, my that. And I could even like print this as I could print Okay. Oh yeah. Okay. I wanted to print them as print. What was it? Path string D for D in the previous return value, and there we go. Anyway, that was a little aside. All right, so I've got a set of these, but I want to make a dictionary of them. Well, instead of calling for a set, what if I called for a dictionary? Now I get an error because the dictionary update sequence has length 0 and 2 is required. That's a bit cryptic, but what I can do is that's invalid syntax. But if I put still invalid syntax. Oh, okay. All right. Rather than calling dictionary like this, I need to just put it in these. Okay, there we go. So for every f in files, and there are repeats, well, there are repeated dictionaries, I'm getting the directory and I'm pairing that as in a dictionary with the value 0. Now, they'll be overwritten a few times, but it's okay. The dictionary will not allow repeated keys, so that's all good. Let me just demonstrate one more thing, right? So like a nice simple one, squares equals, and I can say n colon n times n for n in range 50. Okay, and I need that instead, right? And there we go, right? There's a collection of square numbers, 3 to 9, 4 to 16, 5 to 25, and so on. Can I get a prettier printout? Yeah, I can. Okay, so that took me like no code really to create that, right? So that's a way of building up a dictionary from here. I built it up from a range, right? Here I'm building it up from some files. Okay, so my dir sizes is the f dot directory colon 0 for f in files. Okay, now I can actually, if I return this, because I can now run it. Now I'm not going to. Oh yeah, I won't return that. Yeah, because I'll print that, right? All right, cool. What if I don't pass that one? Now I'm using the real data, and there's my initial set of directories and their size, and their size is set to 0, of course, right? But that just shows you how many directories, and it's not a super large number of directories that we're dealing with. Okay, so I put that back, and what do we do next? So I need to take account of it. I need to go through the list of files. So I go for f in files, right? And then for each file there's a directory, but as I've said, like we need to add, we've got the size and we need to add that size to the current directory and the parent and the parent and the parent all the way back to the root. So I'm going to write this for d in parent chain f dot directory. So given a directory, give me all the directories back to the root. Okay, now that doesn't exist yet, but I'll write it inside here. Okay, go if d in dir sizes. No, the directory will always be in dir sizes. I think. No, that's not guaranteed. You know what? I'm going to make the assumption, and it might be wrong or it might be right. I'm going to say dir sizes d plus equals f dot size. Okay, so I've got a single file, right, f, and then I've got multiple directories up the parent chain, d, and I'm going to look up each directory d and increase its size. Okay, and then return the dir sizes. Now, parent chain doesn't exist yet, so I better create that. I need a directory, and I'm just going to implement this. So in the code I'm looking at, I've actually called it directory, so I'll do that here. And I'm just saying while true, so I'm yielding the directory. So definitely yielding the directory as it stands. And then if the directory is that, then we break. We're not going to do any more. REPL's out of sync. This is annoying. Okay, break. And then otherwise, we're going to go directory equals directory, and then use our slicing trick. Okay, take everything except the last one. Okay, when we break, we'll just break out of the while loop, and then the function will end, and that's it. There's no return value, it's yielded values, right? We're yielding it one at a time, allowing us to do for d in that, right? Get them one at a time. Okay, so parent chain works, parent chain's there, we've got our initial directory sizes, and we've got our process of updating them, and I think it's going to have an error, but it's not apparent yet, and then we're returning the directory sizes. And when I run this, let's just see what happens. Okay, so no error, right? So we've got the root directory has that total size, the A directory has that total size, A sub E has that total size, and D has that total size. And so in the context of our problem, we want to know like the total size of everything that's less than 100,000. So that's that plus that, right? We can get that easily. So how about I do that, right? Okay, so I can say answer 7a, this is one line of code, sum of the size for key value in dir sizes dot items if the size is less than or equal to 100,000. Okay, that's one line of code, and I'll go, oops, print answer 7a. All right, and that's the correct answer for the sample data. Okay, so I'm laughing. Now let's just unpack this line of code a little bit. I'm going to rewrite it. I'm going to, across several lines of code, I'm going to say answer 7a is equal to 0. I don't know why my indentation doesn't work. A bit annoying, but whatever. Answer 7a is 0. And then I'm going to say for directory, comma, size in dir sizes, right? So dir sizes is a dictionary. It has keys and values, and we can iterate through them one key and value at a time, but we have to call that. And then we can say if the size is less than or equal to 100,000, then answer 7a increases by that size. Okay, and I'll comment that. So I've got 4 lines of code instead of 1, doing exactly the same thing, right, and giving that answer. So dir sizes is a dictionary, right? I don't have my squares here anymore, unfortunately. I'm going to just demonstrate something here for you. So a dictionary could be like, Sally is 42 years old and Richard is 37 and Tom is 14. There we go. If I say for x in D, print x, it only gives me the keys, right? So a dictionary is kind of like a set, and each thing is a pair, right? But when you iterate through a dictionary with just one value like that, then it only gives you the keys. Okay, so what if I want the key and the value? Can I just do this? That's being a little bit too hopeful. No, too many values to unpack or something, like the error message could be clearer. What we need is to say items, okay? There we go. All right, so that's how we get the keys and values together. Now, if you go d.items, it's not going to give you a list. Okay, it gives you, that's like a generator. If I ask for a list based on that, then it will give me a list of pairs. All right. So for directory, comma size in dir sizes.items. Now notice that we're not using directory here at all. We don't need to know the name of the directory. So a convention is any variable that's unused. You just call it underscore. It's nothing special. It's a valid variable name, so it's just a convention, just as saying there is a key here, but I don't care what the key is. I only care what the size is. I can actually, I think, probably do d.values. Yep. And I could do d.keys. Okay, so I might actually change this rather than iterate through that, rather than iterate through the items. I'll just say in dir sizes values. Okay, and so now I don't have anything unused at all. Okay, so when I run this, then it's going to give me the same answer. If size is that, then append, right? It's easy to understand. And so hopefully now that we understand that, hopefully we can understand the one-liner, right? We're taking the sum of all sizes for s in dir sizes values if s is less than 100,000, right? Very nice. Okay, so get rid of that. All right, and what if I run it on my real data? I'm going to have a problem. There's a key error, right? And it's this line of code here. I'm trying to add an integer value to a key that doesn't exist. And why doesn't it exist? Well, it's simple. You can have you could have a file inside AE, but not if you didn't have any actual files inside A, then that would never appear, right? So it's perfectly possible to have, a directory structure that has the root and it has A and it has A sub E and it has D. If there are no actual files inside A, then according to our code, we won't ever, because we're going through a list of files and getting the directories from there, then we only get directories that have files in them. If the directory only has directories in it, then it won't show up in our list. So we have to be a bit more careful in this, so that basically this directory D might not exist. Okay, I'm just going to make a little comment here. Directory D might not exist in our dictionary, right? And so rather than doing this unconditionally, it has to be conditional. So I can say if D in dir sizes, right? Otherwise, I'm going to create it. Dir sizes D equals f.size. That's its initial value, right? There's another, okay, let's just run this and check that we're all good. Okay, so there we go. That's on my real data and it gave me the answer, and that answer is correct. Okay, let's see how we could change this code a bit. I could get rid of this. I could not set this up at all, right? So make that an empty dictionary to begin with, and then it certainly might not exist, right? And that's obvious. So I'm going to say if D not in dir sizes, then I'm going to say dir sizes D equals 0, so give it its initial value, and now I don't have to be conditional because it definitely exists, right? And so at the very least it's 0, and I can just not say equals, say plus equals, right? Now, what do you prefer? This approach and then doing that, or the approach where we set up the directories first and then do this? I think I prefer the approach I've landed on now. Why set up some directories if you're not guaranteed you're going to get all of them, is what I'm now asking. Okay, so there we go. Last comment perhaps. I said I was going to look at this before. Makefile needs a present working directory, right? But it doesn't need to be passed in here. It can just take it from the context, from its environment. So if I run this, everything's still going to work, all right? It's not going to say PWD, I don't know what that is, right? If you look at this code in isolation, that should be an error. There's no definition of PWD, but it's not in isolation, it's in this context, and yeah, so there's no need. So this is now a genuine inner function that can't possibly be meaningful outside of its context, whereas change directory, I could cut that and paste that out here and it would still work, and that would actually probably be a good idea because changing directory could have a bit more broader relevance than simply inside process chunk into files. All right, so we've covered a lot here. I'm sure there'd be some things for you to learn and not just about solving the problem itself. Ciao.